let's do some more complicated chain rule problems. So here we've got a situation where you can see you've got a power to the sixth. Okay, so we're going to use the chain rule, usual sort of thing. Outside function, inside function, but our inside function is a quotient, so we have to use the quotient rule when we take the derivative of the inside function. So what happens is, for my chain rule, for my outside function, it's 6, so the derivative is 6 times what's in the parentheses to the fifth, right? And then the chain rule tells me I have to take the derivative of what's on the inside. Okay, so maybe go over here a little bit so I have a little more space here. And now this part just sits there. I'm done with it. Okay, at least unless I need to do something else with it. So here I'm going to take the derivative of this, which is a quotient. Now I just use the quotient rule. And it just multiplies everything here. This is going to be 3x plus 5 squared, right? And now remember, it's going to be the bottom times the derivative of the top minus the top times the derivative of the bottom. Okay? So they can get a little long, and this is even not that bad, right? This is actually perfectly reasonable. So this bottom part, sorry, whoops, it's going to be 5. I don't want to, this bottom is 3x plus 5 quantity squared. Now my top is 4 times 3x plus 5 minus, this would be 3 times 4 is 7x. Okay, so, I mean, there's always a question, how much simplifying should I do? Well, to be perfectly honest, I mean, this, look, these 7x's immediately cancel out, right? So I can do a little bit here. If you left it here, I wouldn't take off points. But we can see, okay, 20, what's 20 times 6? 120. And then this would be 3x plus 5 to the 7th. Okay? But yeah, if you left it here without really simplifying, no, see, that's wrong. Look what I did, you guys. That's what happens when you try to do it in your head. No, this is right, but it's not 7. It's 4 times 3, not 4 plus 3. All right, let's fix this. Oh, man. Okay, so I have 6 times 4x to the 5th, and then I have 12 minus 7 is 5x plus 20. All right, yay. Okay, well, just that's a little bit better, right? 12 minus 7 is 5, right? Okay, so fine, we can leave it that way now. At least it's right? That's one of those things. If you leave it here, you don't end up messing up like that. Sometimes you do have to take it further, because sometimes we'll ask questions like, find where the tangent line is horizontal or whatever. So just solve that it's where it's 0. When you have to do it, then you have to do it. But if you don't have to simplify, it's typically okay with me to just leave it there. On the test, I mean not on the test, on my test it's fine. On the finals, sometimes they want you to simplify more, but it will be in the directions. It'll say, like, simplify completely, or you don't have to simplify completely, whatever it is that they want. Okay, so do be aware of that. Now let's do a slightly different one. What do I have here? Something similar but different. So that you can look at the difference between these two things. This one also has a quotient in it. But you'll notice it's something to the 7th divided by something to the 5th, and it's not some, we can't really do much to simplify those because of the numbers. In some sense, the outside function, as it were, is the division, right? I've got something divided by something, so the biggest thing, the first thing I look at is, this is really a quotient. So I'm going to be using the quotient rule. But when I come to take the derivative of the top and the bottom, those are chain rules. So it may not always be that the chain rule is the first thing you use. In this case, the quotient rule is the first thing you use. So for my quotient rule, I'm going to take the bottom and I'm going to square it. The whole thing squared so that becomes a 10. And then I've got the top times the derivative. I'm sorry, the bottom. I said it right. I said it wrong. I wrote it right. The bottom times the derivative of the top, right? I was writing it the right way. Not doing great today, huh? And then derivative of the bottom, which is the 5, right? 5. So I'm going to come over here. We can see this a little better. So I end up with 3x squared plus 2 to the 5th. And then the derivative here is going to be the derivative of that. So it's going to be 7 times 4x minus 8 to the 6th times the derivative of what's inside the parentheses, 4x minus 8. You don't have to write that as a separate step if you don't need to, but because this is new, I'm going to. I probably should have started even further over there. Now look at this mess. Okay, minus 4x minus 8 to the 7th. Now the derivative of this, it's going to be chain rule 5 times 3x squared plus 2 to the 4th times the derivative of 3x squared plus 2. All right, let's clean this up here. I'm just going to move all the way over here. Okay, so this is 3x squared plus 2 to the 10th in the bottom. This first one, I've got this times 7 times this times the derivative of this is going to be 4. So I'm just going to put those together. 28, 3x squared plus 2 to the 5th, and 4x minus 8 to the 6th. And now in this second part, I've got this to the 7th, this to the 4th, the 5. And then the derivative here of 3x squared plus 2 is going to be 6x. So I'm going to pull the 6x out, put it in the 5. That's going to be 30x. Times 4x minus 8 to the 7th times 3x squared plus 2 to the 4th. Okay? And again, if you want to leave it like this, it's okay. We can notice that we can also do a little bit of work in terms of cleaning this up. There's 4 of these, 5 of these, and 10 of these. So I can pull out 4, boom, 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 right? And then notice that there's 6 of them in set, so I can pull this out. 4x minus, I just don't even have the space to do this. Then I would have 28, 3x, I don't have the space. I'm just going to leave it the way it is. Just leave it the way it is. And that's another thing. On the web assign, you can leave it the way it is. You can clean it up so that you don't have to type in so much stuff. But, you know, either way.